Alright, to make the converse of theorem 1 true, we need one extra axiom called parallel axiom. So here it is. P1. If P is a point outside of the line, then there exists a unique line passing through the point P and also parallel to the given line L. Right? So the uniqueness is the key. So you cannot have more than one, and you have to have at least one. So you have to have exactly one. All right. So here's the theorem 2, which is the converse of the theorem 1 we just looked at. All right. So let's assume that L is parallel to M. So given would be L is parallel to M. So in this picture, so M goes through B, which is the exterior point. So B is in L, and this M is parallel to L, right? So this is given, right? Then we want to say that the congruent alternate interior angles are congruent. So I'm going to just number it. So this is again angle 1 and angle 2, right? So let's say 2, right? Let's assume that they're not congruent. For the sake of argument, we're going to assume that the angle 1 is not congruent to angle 2, right? So this is just the assumption for indirect proof. Oops, it looks like a roof. Right, proof. All right. So if that's the case, we can find, so let's say find a ray, so let's say BC. Right? So we know that 3, right? There exists a ray BC such that angle ABC, oops, I should say ABC matches the angle 1, right, which is this guy. So we know that we're matching this guy with that guy. So this is just the angle construction theorem. So I'm just going to say construction theorem. Right, so do that. Then you can see that if you extend this ray CB into a line CBC, then you can see that we're going to call this guy M prime, right? 4. We know that the M prime go through. Oh, actually, I made a mistake up here. So this is not L, so this was M, right? So B is on the line M prime. So M prime passes through point B, and right, M prime, which is CB, so M prime, which is line BC, actually is parallel to line L, because they have the congruent alternate interior angle by theorem 1. So we know that this is theorem 1, tells you that they are parallel, right? Then this is actually a contradiction. So here, oops, right? Because we have M goes through B and parallel to L, and we have another one go through B and the parallel to L at the same time, so we cannot have 2. So this violates P1, right? So therefore 5, right, we know that angle 1 must be congruent to angle 2, which means that they have congruent alternate interior angles, right? That's it. So with this added extra parallel axiom, the converse of theorem 1, which is theorem 2, is actually true, right? That's it. I hope that this was clear.